Okay, for these examples, we're still looking at special factoring products or special factoring patterns. Here we have a z cubed, and 125 is just 5 cubed. So we have z cubed minus 5 cubed. So for this we can still use that pattern that we've developed for the minus. So that would be the a minus b, or z minus 5, and that would be times then z squared minus the product of the two a and b, so 5z. Actually that'd be plus 5z. And then we would have plus the 5 squared, or b squared. 5 squared is 25, so we'll replace 5 squared with 25. Okay, so that's all there is to that one. Now let's take a look at this one. Now this one is going to require that we look at a greatest common factor first, and then see where it goes from there. So the first thing I'll do is I'll take 3y. I have y in both terms, and both are divisible by 3. So I'll take a greatest common factor of 3y out, and 3 into 81 would give us, let's see, 27, and y into y to the 4th would be 4 minus 1, or y to the 3rd, and then 3 into 192 would give us 64, and y into y cancels, so that's out. So this is our new number we've got, and we'll keep the 3y. We'll put 3y over here, and then what we've got to look at is we've got the 27 is 3 cubed, so I'll rewrite that as 3 cubed. Well, actually I'll put them together, 3y cubed. So that's similar to an a cubed in the pattern we established earlier. And then the 64 would be similar to, put it here, 4 cubed. 4 times 4 is 16, times 4 is 64. So the 3y looks like the a cubed, and the 4 would be similar to the b cubed. So now we've got a pattern for that. And we'll just carry the 3y over. We're not doing anything to that. And then our pattern, we have an a plus b, which is 3y plus 4. And then that's times a squared, 3y squared. We're running out of room here, so let's just put that underneath. So 3y is still over here. And then we'll have the a would be 3y, and the b would be 4. And then a squared would be 3y squared. Okay, and then plus the product of the two, 4 times 3y, which is, and it'd be a negative, so minus 12y, product of a and b with a minus sign. And then we would have the b term squared. That would be 4 squared. Okay, so 3y squared, 3 squared is 9. So we replace this 3y squared with 9y squared, and then 4 squared is 16. So that's our pattern for this one, and that is our answer. Okay, let's do one more. Let's do factoring by grouping. Okay, now we're going to look at an example which gives us factoring by grouping, and then we'll see where it takes us from there. So this example is x cubed minus 2x squared minus 9x plus 18. Alright, we're going to take a look at this, and we're going to see, first of all, we'll take this side and see if we can find a greatest common factor here, and then we'll take this other side and we'll see if we can find a common factor there. So over here we'll take x squared out of these two terms. So we'll have x squared times, let's see, x cubed divided by x squared leaves me with an x. Minus 2x squared divided by x squared leaves me with a minus 2. Alright, now, what can we take out over here? Well, if I take a minus 9 out, minus 9 into this first term leaves me with an x. Minus 9 into the second term leaves me with a minus 2. Okay, now I can look at these two expressions, and I can see I've got a minus, x minus 2 is a common factor in both. So I'll take x minus 2 and I'll put it over here. And if I divide this first term by x minus 2, I end up with an x squared. And if I divide this second term by x minus 2, I end up with a minus 9. Okay, so now by grouping I've factored this to the point I have x minus 2 and x squared minus 9. Now if I look at x squared minus 9, this is an example of a difference of squares. So I can factor that by, if I remember the pattern for difference of squares. So I have a square here and I have a 3 squared here. So this becomes x minus 3 times x plus 3, and I still have this other factor, x minus 2. So we used two things here. We factored by grouping. We grouped the first two terms and took a common factor out. We grouped the last two terms and took a common factor out. And then we were able to take this x minus 2 common factor out of both and end up with this and this. And then here we had a difference of squares, so we had another pattern where we could do an x minus 3 times an x plus 3. Okay.